Okay, so last lecture I will talk about fairness that we talked a bit in the introduction, and software publication. So we'll see that the FAIR principles that Romain talked about in the introduction can be applied to software. Actually, it's called the FAIR for research software principles, and how they can be applied in practice to publish your software. So we will talk about also license for your software, how to create the metadata and citation files, how to version and release your software and publish it. So this week, without really mentioning them, we have actually covered a lot of the quality dimensions for research software. So for example, talking about the virtual environments, it helps for the flexibility and maintainability, the unit testing as well for the maintainability and functional testing. For the more advanced topics, profiling and optimizing helps for the performance efficiency, etc., etc. Security as well. But one important dimension of the software quality that we have in the EVERS framework is fairness. So FAIR, as you know now, is these 4 principles: findable, accessible, interoperable, and reusable. And they have been developed more for data objects. So software is a kind of data, but it has its own principles. And yeah, so fairness is all about discoverability and reusability of the data. It's a part of quality. It ensures discoverability and reusability. But it's not all the software quality, of course. There are the other dimensions that we saw before. So if we try to apply these principles to research software, people have thought about that. And there is actually this paper here defining the FAIR for research software principles. And we can list them. So in the findable, they recommend that you assign a unique and persistent identifier for your software. It's better to have IDs for different components of the software, for example, different modules. Sorry. And different IDs for different versions. It should be described with rich metadata. And the metadata explicitly points to these identifiers. Finally, these metadata, they should be searchable and indexable, so they can be used by also machines, and we can use them to search and find your software. Accessible means that we can retrieve the ID or the software using standard protocols. So for example, HTTP, things like that. Authentication when needed. The metadata should persist if the software is gone, meaning that we should still find, oh, this software has existed. It was for that and at this license, even if the software is not here anymore. For the interoperable section, it should meet the community standard for exchange. So for example, to use data formats that are used by the whole community. Qualified references to other objects. And for the reusable section, we should have rich and accurate attributes. For example, a clear and accessible license. We'll see why this is very important. A detailed provenance and history, so how it has been built. So for example, the Git history will help for that. You should add references to other software if needed, or if you use other software. And meet the domain-relevant community standards. So these are the principles, and we'll see now how they can really apply in practice, what it means. So for the unique identifiers, we have mainly two big frameworks that I will show, Zenodo and Software Heritage, that will provide you this DOI or Software Heritage ID. For the standard metadata, there are two main metadata schema or formats that you can use, code meta and citation, and same will apply that just after. And for indexing, you have all the big registers like Conda Forge or Pypy, or more specific registries in your specific domain, for example, that will help people to find your software. So standards, I mentioned HTTP, also pip install is a way to access the software easily. For the metadata longevity, archiving in Zenodo ensures that the metadata will stay. So even sometimes you will find records in Zenodo where the data is not accessible anymore, or it's under an embargo, so you cannot see yourself the data, but you can see the metadata, so see what's inside. For the standard formats, there are some formats that are used in all the domains, CSV, JSON, HDF5, but you can have also community-specific standards, and you should really use these to, for example, for the output of your software, so people can reuse your software. So again, you can reference to other software using their DOI. And you should also use controlled vocabularies. So Romain talked about that because he's an expert in ontologies. That means that if you have a domain ontology specific to your community, you should use that with clear definitions and use standard terminology to make sure that people understand what your software is about. For the reusable section, for the documentation, we have the README file and the docs, as we have seen yesterday with things, to build your API doc. You should also add a user doc to explain how to use your software. The license will talk more in length. And for the provenance and community, there are files like contributing and changelog files. To assess the fairness, so we talked about the tools this morning. There are also some tools available to assess the fairness of your software. One is the Fair Software Checklist. So it's something manual, like the checklist we are creating for the school, to check that your software is fair. And there is also one tool, How Fair Is, which works with a command line and online tool. We'll actually, test it just after. I must say that the purpose of this tool is not to evaluate strictly your tool. It's more to give you guidelines and help you improve the fairness. But yeah, don't if something is not passing, try to improve it, but don't feel too bad about it. So first exercise is to use How Fair Is. So there are different ways to use it. You can choose your preferred one. You can pip install How Fair Is and run on your GitHub repo. You can also use Docker if you don't want to install it. So there is a How Fair Is image here. Or you can go online to the howfairis.com website. You will need to connect with your GitHub account. So here I'm logged in. And is this the internet? Oh, yes. Internet is a bit slow. These are all my repos, and you can trigger How Fair Is on your repo. So I will give you 10 minutes now to do that and try How Fair Is. And if you try on your laptop, this should be the output, something like that. And you saw on the website how it looks like. And the result should be pretty bad at the moment on the pCoffee repo. So we'll try to see why and how we can improve that.
I see on the site that we can have badges, and we can keep data and follow the progression of how our code is fair.
Yeah.
Do you know if it's possible to use the tools locally and then send after the data to the website?
No, I don't think you can do that. The server doesn't allow you to send data. It just pull. You can just pull
So you just can check the repo.
So if you run locally, you can make your badge also locally and upload it to your GitHub repo. But then it's static. So if you improve the fairness, you will have to rerun the tool locally and change the badge.
Okay.
But you can also run it in the CI.
Yes.
So, and this will be automatized. So, yeah.
Okay. Just I was thinking on the way to do that, and just to not apply the check on each CI, but can have the information, but not publish the information. So to choose which data we can push to the site, but the website. But in the CI, I think that we can use maybe that on only on merge requests.
Yeah, for example, yeah.
On pull requests, sorry. Okay.
Okay. Shall I continue? So we'll try to rerun offerings at the end of the lecture and see if we have improved on it. Then we'll talk now about the metadata and some essential files that you should add to your repo. So first, licensing. So why license? The license defines what others can do with your software. So it's a legal information. It's also part of the FAIR principles. But if you don't have any license in your code, actually no one can even use the code. So it makes it pretty useless. Even if it's open source and everyone can find the code, legally they can't do anything with it. There are different types of licenses, 4 main categories. The public domain means there is no restriction at all, so you can do absolutely whatever you want with the software or the piece of data. For example, not very, but old art pieces are in the public domain, like old songs, things like that. Then you have the permissive category, like the MIT license or Apache 2, with very minimal restrictions. Usually you can do almost everything you want. Sometimes they require that you just cite the software, for example, if you use it. Then you have the copyleft license, like the GPL3, which I think is the most common for the copyleft ones, which imposes that you share the software with the same license. So you can do almost whatever you want, but you cannot make a non-open source license based on this software. And then you have all the Creative Commons licenses. This is more for data or documents, but not for software. Some popular ones, so I just mentioned the MIT license. This is probably the most popular license in research. It's very simple and very permissive. You can reuse the software for anything, so commercial use, you can modify, distribute, private, and it protects the developer for issues that could happen with the software. This is also an important part when you add a license, it usually mentions that you are not responsible for what people do with your software. So it just imposes for the MIT that derived work must include a license. Apache 2 is almost the same as MIT, but it protects your trademark. So if you have a name or logo for your software, it will protect this. And protect explicitly for grants for patents related to the software. And also, it states that people reusing the software or modifying the software must state the changes. So they should include a notice file saying we have taken the software but changed that and that. And that's it. And then GPL3, so as I said before, the derivatives must be open. So you can't reuse the software or modify it and make a closed source version. It also has the patent grant. Yes, because of these limitation, it can limit adoption and can make it incompatible with some other licenses. So it's not compatible, for example, for the other two here, because you have this derivative section. To find the right license, you have a very nice website. Choose a license that will help you find the right one for you. So you see here, they recommend, for example, MIT if you want something very simple and permissive. But you can see more licenses here, the different version of GPL, the Mozilla, etc. There are more licenses than on this website for more specific use case. Okay, so I would personally recommend MIT if you just write something that anybody could reuse. So this is actually the exercise step. Add a license to the pcoffee. So you can choose any license. I authorize you to add whatever license you want. For your specific project, you should consider your goals for your project in your community, and also you might have some requirements from your institute or funder. Sometimes they apply some requirements. And so to apply the license, you can just create a license file or license.txt, copy the license text, and you should just fill the year and the copyright holder, probably you, but that can be also your institute, depending on what they apply. We'll see after for the code meta and citation.cff, but you can also update the PyProject.toml to specify the license. And optionally, you can also add a license header in all the Python files. So in the source files of your code, you can add a header. So as an example here, here's the MIT license. So you could copy this text and replace here the year and copyright holder. In the PyProject toml, you can add it like here. So either you mention directly the license code, here MIT, or the file where to find the license. And in the header that can look like this, so at the beginning of the file, you can add a header like that to specify the license. This can be useful if you have different licenses for different parts of your code. That happens sometimes. So at the moment, you can just create this license file and modify the pipe project. Who has software in their repo or somewhere else without a license? Only one? That's very good.
We are using the Cecil license.
Yeah, it's a French.
French, yes, it's equivalent to MIT license, but with
it's a bit more restrictive, I think.
A little bit, but it's adapted to the French and the European right.
Yes.
And not the American. So for project, it sometimes.
Yeah. So I know this license. I know some people here are using this license because of that, because it's recommended by the French government, basically. The problem is it doesn't comply very well with other licenses. So when you integrate with other software, sometimes there are some limitations. Okay. You want to? With GPL, exactly. So it's a copyleft one. So all the derivatives must be also open source. Okay. Since you all knew about licensing, I will continue. So now I will talk about metadata. So metadata we mentioned a bit during the week, but just to make sure, so what is metadata? It's some structured data that will describe your software. So for example, the name, the version, the description, all metadata, the authors and contributors, the license, the repository URL, where to find the software, programming language, dependencies, and documentation links are all metadata. So there are some data that help to describe your software. It's even better if you can have metadata which are machine readable to allow other services or search engines to index and find your software. So what I just said, findability. Also automation. So some tools can process structured metadata, and we will see some of them, like platforms, Dependabot and Software Heritage. And you can also make automated citation generation. And different use cases need different metadata. So for the citation, you need to specify the authors and DOI. For the replication, you need to specify the dependencies and version. And keywords and description will help for the discovery. So there are common standards for software. We saw one actually, PyProject.toml is actually describing your software. You can see inside name, description, etc. We just added the license as well. But it's language specific to Python. We have two other formats that are not specific to any language and good for software. The first one is code meta. So it's a JSON LD format based on schema.org. Schema.org is a very big schema used on the web for anything. So here they derive from schema.org a specification for software. It's a simple codemeta.json file that you can add to your repo, and it's now widely supported, especially by Zenodo and Software Heritage. And you have also the citation.cff format. This one is a YAML format. It's very good for academic citation. It's made for that, to specify how to cite your software. Here again, it's a single file citation.cff that you add to your repo. It's natively supported by GitHub. So when you add this file, you will see a new button, Cite this repo, when you go to the repository main page. It's also supported by Zenodo. And you can specify here how you want your software to be cited. So here is a comparison of the two. So a good practice would be to use both because they don't have exactly the same, they are not made for exactly the same thing. So codemeta.json is much more comprehensive to describe your software, and citation.cff is really made for citation. And you will always have your language-specific files. The Py project will stay there, of course. So this is an example for CodeMeta to show you what it looks like. So you see here all the metadata. Or, for example, an author is described with a name, email, affiliation. You can even have the ORCID, for example, in the format, license, etc. To produce this file, we have some tools available. You can also make it by hand, of course, but it's much more friendly with these tools. So there is this CodeMeta generator, which is a web form where you fill all the information about your software in a web form, and you get the CodeMeta.json. SumF is a command line tool that does automatic extraction from the files that you already have, for example, from the pyproject.toml or from the GitHub API. And AutoCodeMeta is based on SumF, but it's a web service, so we'll use that just after, actually. And you have some lookup tables to crosswalk from different formats to CodeMeta. For citation.cff, it looks like that. So you will find, again, the same kind of information, but with this specific field for citation, preferred citation, and you can here also mention some paper related to the software. Again, we have a web form to produce this file, and a validator to make sure that the syntax is correct. So this is your turn. You will have to produce these two files, CodeMeta and citation, using the AutoCodeMeta and the CFF init. Download the files and add them to the pcoffee repo. So I'll do that in parallel. So the AutoCodeMeta, it looks like that. So here you see that it waits for the GitHub URL. So coffee, yes. So I just copy. You should use your own fork. And voila. I have all the metadata pre-filled here. So it found the description from the README file, the creation date from GitHub probably, the license. I can add also some more metadata here. For example, funding code and the funder. So here I could add the, I'm not sure. I think the open commission I should put for our projects, and the funding code I can find later. It found by itself, of course, the code repo I put, but the issue tracker, the programming language as well. I can specify more things here if I need. I can, so it found only, probably with Pixie also it doesn't integrate very well, so it found only UV build in the software requirements, but I could add more here. Version number also, it didn't find it. I think we had the 0.1.0. I can add a reference publication. So we have a publication for the pCoffee project. Very nice journal paper. So to cite, I need the DOI here. Title, extra. Okay. You can add the author. So here also you can find Champ Dupont. Okay. I can add some additional info here. I don't need anything. It found, well, it found me, but only my email address, so I can complete that. I will add the S3 school as authors as well. So this is a different type of authors. You can see here, there are organization or person. So this is an organization and here person. And this is my code meta. Just make sure to regenerate because I added some information, and then I can download the file. Okay. Seems the internet connection is okay. I can also copy and paste and create the code meta.json file. And I would add this in the root directory of my repository. So let's do that. Add a file here, code meta.json. Okay, I have my file here. Ah, wait, I copied. This should not be here. Okay. Yeah, clean up code meta. Good. I will let you do the same for citation.cff. Yes. Okay, I can add maybe. Okay. And same, I can download the file and add it to the repo. Okay, let's see. And now I have the button here, cite this repository here in the GitHub page, where I can export that in BibTeX, for example, to cite in my paper. Okay, I will continue. So you had time to at least add one to your repo, because this file will be used as a source of metadata just after when we publish the paper on Zenodo or on Software Heritage. So as a summary, essential files that you should add to your repo for publication. So the README, you have one example in the repo, but you can improve that. You can add many things in the README. It's a human readable file, so it's not made for machine. So it's not very structured, and you can add anything you want, but these are the basic things you should add in the README: the description, how to install the software for other users, how to use it, basic usage instructions, and citation. And some contact details maybe, or you want people to reach to you, their issues or things like that. License, again, of course, mandatory. The metadata files we just saw. Two other files I want to mention, contributing.md. These will tell your fellow contributors or fellow developers how to contribute to your code. If they should first discuss with you to add a new feature through issues, for example, or not, if they can contribute or not, etc. So they know what to expect, and at least you have a sort of process that they can follow. You can find many good examples of contributing.md online. It can also state the code of conduct, so to make sure that everyone behave well. There is also the changelog, also Markdown format. This is to track the changes in your software between releases. And finally, the docs. We have talked about that. I won't mention it further. So now that we have all these files, we can go ahead to actually publishing the software. So just to say that publishing is different from just code hosting. So code hosting will happen in GitHub or GitLab, for example. This is very good for version control, collaboration, issue tracking, etc. But it's not really publication per se, like a paper publication. So full publication should include the file we mentioned, plus packaging and releases with a version management system, and archiving for long-term preservation. So it's the final touch to make your software really fair. So what is a release, actually? A release is a snapshot of your software at a specific point in time to make it available to users. So it should include a version number or name, a changelog to say what's new in this new release, with a release note, and optionally some artifacts, so for example your binaries or packages. You should probably use versioning scheme, and I would recommend to use the semver schema. So in the semver schema, you have three numbers. You have seen that in many places probably, but they have some meaning. So the first one is the major. The major number. It changes when you have breaking changes. So when your API in your software changed and there is no backward compatibility. The minor for new features. So you added a new function, new things in your code, very nice, but it doesn't break anything from the previous version. So people can still use the new version in their code. If they don't use the new feature, it's fine, but it won't break their own code. And finally, the patch for bug fixes. So when you really make a small update to fix a bug without adding new features. So for example, 1.0.0 would be the first stable release. Sometimes we start with the O dot something, like in pcoffee. Usually when we haven't reached the 1, it means that the software is not stable and subject to change very rapidly. So this is something users should know. So starting from 1, it's the first stable release. And then when you add a new feature, it will be 1.1.0. And once you break the software or make a breaking change, you can bump to version 2. There are some automated versioning libraries. It's a bit more advanced, but I think worth mentioning. You have the setup tools SCM. These will infer the version or provide the version based on the Git tags. So when you tag your version in Git, it will use that as version. And between tags, you will have this weird versioning schema, which is based on the last tag plus a dev version from the commit, from the last commit. This is nice because then you don't have to manually update the version yourself. When you make a tag, it automatically updates the version in your code. So to do that, I added here, you can see what you need to use setup tools in your Py project and Pixie. And then you have Python semantic release library. This is even more advanced. It automates versioning, changelog, and tagging based only on your commit history. So it has a strong requirement that you use conventional commits. So this is a way to specify in your commit what you did. So for example, when you add a new feature, you add this in your commit, fit dot and your commit message. When you fix something and when you make a breaking change. Some libraries that use this convention, you cannot commit if you don't use this convention in their library, so you can't make a pull request extra. This is because after that, they don't deal at all manually with the version. The library Python semantic release will infer if it needs a new version based on the commits. So when you make a breaking change, it will automatically know, okay, we need to bump the version, the major version number extra. Okay, I have a loading error here. I don't remember what was here. Not too important. Okay, so now to create a GitHub release, these are the steps. You need to update the version in your code. So in your Py project TOML, code meta, and citation CFF. Of course, you should make sure that all the tests pass to not release a buggy software. And then you can go to GitHub, go to releases on the right. So I will also do that to show you, and you can do it as well. Draft a new release, create a new tag, write some release notes. You can generate at least the basic notes based on the past pull requests. So that's why also it's important to use pull requests. Even if you are on your own in your project. And it's good to add some summary maybe on top of that. And you can attach binaries if needed. And then you can review and publish. And we'll see after that it can trigger the Zenodo integration. I added here node templates that you can use. Yeah, you can the release notes. You can also have your own structure. It's a text file. So let's see on the pCoffee. So on the right here, you can create a new release. You can select a tag. So if you did git tag before, you can select a specific tag. For example, here we had tagged the day 0. Or you can create a new tag. So these will be, for example, version 0.1.0 from the main branch. For the title, I will also use the same tag versioning schema. And here for the node, so if I click on generate, this is what I get. So you can see GitHub provides me with the list of contributors with the pull requests related. And based on the pull request title, also make a list here of what happened. Here I could add some nice message. See, this is the first version of pCoffee. And probably there are other changes that are not listed here because we didn't make pull requests for everything. So maybe I can check and add manually other stuff. This will look like that. I could add the binary. Here I don't have one yet. So let me publish that. Good. And then we have the list of releases here in the release section with our first one. It bundled the code, the source code, as a zip or tar archive here that I can download. And that's it. So here, when I go back to the main page, I can now see the release with the first one I did. Okay. You can also distribute your package through Mypy. So first you need to build your package. So this is based on the pyproject.toml, so you must make sure that this one is complete. So with all the dependencies and build system, but also with the metadata, because this will be added to Mypy. You need these two tools, the build and twine, build to build the package and twine to upload to Mypy. And then to build, it's simply python.m build. This will create the wheels and tar archive in the dist directory. And then to upload to Mypy, so you will need to create an account on Pypy, and I recommend also on test Pypy, where you can generate an API token in your account settings. And then to upload, this will be the command. So try and upload. Here you can start first on test Pypy with this -- repository test Pypy, and use everything which is in dist. Strongly recommend the test Pypy first, because once you have uploaded on Pypy, you cannot remove the package anymore or touch. So if you made some mistake, or so make sure everything goes right on test Pypy before going to Pypy. And then you just remove the -- repository to upload to Pypy. For pCoffee, you won't be able to publish because there is already a pCoffee project on Pypy, so you can't push your own. But you can try maybe right now to build your own version. Instead of pip install, you can of course use Pixie. And that should work out of the box with the Pipe project we had.
What about if in our project we have several environments, for example, production,
It will use the default.
So if we want to build, we should use production, right? But we install this in the production environment so that we can build.
Well, you could, yes. You should do it in the prod.
But this
you can make a build also, a build environment.
Because this doesn't include the dependencies, right? It's only...
No, yes, it will list the dependencies, because when you do the pip install, if there are dependencies, you want them to come as well. So this goes in the metadata in Pypy, and when someone else do pip install, everything comes with. As you have seen, when you do any pip install library, you can see all the dependencies coming as well. So yeah, it should be the prod environment. Did you manage to at least build it? I'll take 4 yes. And yes, last point. Of course, you can again automate the process with GitHub Actions to publish a new package when you make a release. So when you do what we did before, create a new release extra, this can trigger an action that will build and upload your package on Pypy.
Just a remark. I've tried. I use the test Pypy, and I met some issue because all the package are not in test Pypy. You know, if you have dependencies, and I run my
then
my
to
package.
Install your own.
Yeah. No, it's I tried to run my package, and sorry. And he tried to install a very old version of some package. So I didn't understand why. And I just think, okay, maybe there is a problem. I list the package available on test Pypy, and it was very old packages because the maintainer of the packages didn't publish the last version of their package on PyTest. So you have to add an option. You know, I think you have to add extra repository and indicate Pypy as extra directory repository. So with Twine, you will find the dependencies and can get the good dependencies. I spent quite a time with this issue. So
thanks for sharing. So it's when you want to, then you upload it to test Pypy and you want it to pip install from test PyPy, your package, and then the dependencies come from the test PyPy, which were not good.
And not from.
Yeah. So change. What did you say?
It's extra index URL.
Okay.
No, with pipe style.
Thanks. Okay. And now, why archive software? So the problem is that GitHub and GitLab, where you store your software and develop, are not archives. So first, if you use github.com or gitlab.com, they are commercial platforms, so they can change their policy or just stop the service anytime. Repositories can be deleted. URLs can break, so you have no guarantee of permanence for your software. So what happens to your software in 10 years? Will it still be available on GitHub? Platform change, etc. So one solution is to archive the software in dedicated platforms. So through archives, they will provide long-term preservation for decades, persistent identifier, so DUI, for example. Metadata preservation, we talked about that. So the metadata will stay even if the software is not there anymore. So at least we know what was inside. And they provide discoverability for academic system and integrates with citations. So the two I want to mention are Zenodo and Software Heritage. Maybe you know them already. So Zenodo is a really general purpose archive developed and hosted by CERN. It's completely free and open. Even the code running Zenodo is open source, and you could have your own Zenodo platform in your institute. You get a DOI for each version that you make, so you could also upload data or any document and have the different versions. It integrates with GitHub. We will see that just in a moment. And it's also part of OpenAir. So it's very good for software, but also datasets and supplementary material. For Software Heritage, it's really dedicated to software. So it's a universal software archive supported by UNESCO. It will preserve all public source code and provide also an identifier, the SWID. It makes the archiving completely automatic. So once you have registered your repo in Software Heritage, you don't have to care about the different release, version, extra. It will release, it will archive everything and every Git commit. There is now a link from HAL, so the French HAL system, to Software Heritage. And as I said, so it follows the complete Git history, and it will preserve that history. So you have a much more granular identifiers. You can cite a very specific commit of the software. So this is really good for software because it makes for that, and to be able to cite a specific part or commit. My recommendation, use at least one. So we'll see the Zenodo and setup and GitHub integration, So for that, you can go to zenodo.org. For this exercise, maybe start with sandbox.zenodo. It's a complete replicate of Zenodo, but that gets emptied from time to time. So it's made for tests. And in Zenodo, you can log in directly with GitHub, with your GitHub account. And then go back to the, in the Zenodo settings, there is a GitHub section, and you can toggle your repo. So I will actually show that. We go to the end of the setup. And then when you create a release in GitHub, as we have seen before, Zenodo will automatically archive the source code and make a DOI that you can use to cite your software. And if necessary, you can update the metadata on Zenodo. And then you can go back to your README and add the Zenodo badge as we did before. Important point, the metadata used, if you added the code meta or citation file before, the metadata will come from these files. So they are the source of metadata for these archives. Okay, I have some loading issues here. Can't see the badge in my slide, but we'll see what it looks like. And each release in Zenodo gets a separate DOI with what they call also a concept DOI for all the versions. So this way you can cite a very specific version. So exercise do it for the sandbox. So here, if I log out, okay, I can log in with GitHub. Like that. Then in my settings, if I go to GitHub here, you can rethink, but okay, did it 2 years ago. You can here it will list all your repos, and then you can just toggle the repo you want to archive in Zenodo. So if the sync works, I will be able to find pCoffee. Doesn't seem to work, but okay, let's pick another one, doesn't matter. For example, AGNPy, and I just switch this button. Very simple. And then when I will make a release, that will make a new record in Zenodo, so I can show you what it looks like. Maybe in the real one. So if I go then to my dashboard, I can see so there are different types of records. If I filter by software, here we can look for one record. So this is CTA plot, and here I can see a zip archive with the source code of the library that I can also download from Zenodo. You can see here on the right all the versions. You can see that it's also linking external resources, so the GitHub repo and OpenAir, and also a link to Software Heritage now. Zenodo and Software Heritage have a partnership now. And here I can find my badge, so the DOI that I can copy, and other information. And also the citation here, so it will provide a citation block. You can use that to copy to pip-tech, for example. Once you have done that, you can go back to your repo to add the badge. So that I copied from Zenodo. Didn't copy the full badge, I copied the... So I need to click on the badge here and find, here I use Markdown, so I will copy. Sorry. Like that. And this is the preview. So this will show people that they can cite the software or find it on Zenodo. Software Heritage works a bit the same, but you'll see it's even simpler. To save a code, you go to this page, Archives of Software Heritage, Save, and you just add the Git URL, or the GitHub or GitLab, or other platform. So you can see also you can upload a tarball or other sources. In our case, that would be that. And just submit. So it has been accepted, it will be processed soon. Good. And then, if I can show you an example, for example, with the software Mypy. So if I go to their page on software heritage, you see that we can again find their README file showed here and all the source code. I can get the full history here with the branches and release. So you can also find the branch. So if you use a specific branch to produce some scientific results, you can say, I've used this specific code. And if really I used a very specific commit because there was a bug fix, but it wasn't released yet in a released version, but I needed to produce my result right now. So I can find one specific commit. And here on the right, you have the permalinks. So here you will find the software heritage ID, and also here the citation file that I can use with the specific SWID. And this citation file is based on the codemeta.json. You see now all the citation.cff or codemeta.json file are used by the platforms to harvest the metadata. Okay, so this is how you can release your software and get your DOI, and then people can cite nicely your software. So this is my checklist for publication. So before release, make sure you have added a license that we did, that your README is quite complete with information you want to give to users, that you have created the files codemeta and citation.cff. Of course, again, that your tests are passing. You have some documentation. The code is formatted and linted. You have no security issues, and you have a changelog file. And for each release, so you should bump the version following the same schema that we saw. Update the changelog. Again, tests are passing, documentation. I create a git tag. This I can, if I use the GitHub release, the tag will be created automatically. I have to write some release notes, and then it will be archived on the Nodo or software heritage. I get my DOI, and I update the README. And I can tell my users there's a new version. And I would suggest that you add this checklist in the wiki of your repo. So when you want to make a new release, you can go to your wiki and have this checklist and make sure that everything is okay. So at the end, after everything we have done, you can try again the offer ease and compare if it improved or not. I hope it won't take 20 minutes. So. So for me, for the pCoffee repo of the school, it finds now, so as open repository, it was already the case, as a license. And it now finds also the citation file and the codemeta file. So we have improved the citation section. I did not commit the Zenodo batch. That's why I didn't find it. I should have pushed. And registry, I did not add also the PyPy badge in the README, so I should do that to make sure that people can find my software on PyPy. So we went from 1 or 2 to at least 3 sections, but actually I could complete also that easily because I have the PyPy version. The last one, the checklist section, is if you go to the Open Software Foundation, they have this web form. It's a quite long checklist web form where they ask a lot of questions about your software. So it takes some time, but it's really a very in-depth assessment of your software, and then you get also a badge that you can add to your README with a percentage of what you achieved. So it covers security mainly, but many different things as well. Okay, did you manage on your side? Your queries? Let's say yes. So I will end now. So the key takeaways, we have seen the FAIR principles. We have seen the essential components that make the FAIR principle in practice. Again, I have these loading issues. I hope you can see the slides well in the PDF. It's just the pipeline or framework that you should follow to publish your software. And again, some resources for you to go back. Any question on what we have seen today? Yeah.
Well, does CNRS ask for any specific license, or is any license incompatible with CNRS?
No, incompatible I'm not aware of. And it will really depend on your institute and domain. So probably that's, for example, in medical labs, they have more specific license extra. So not at the CNRS level, I don't think so. So ask your lab or institute. And myself, for code, which is really open, I use MIT and don't ask. No other questions? Okay, well, we are right on time for the end of the school. So with that, I will thank you again for your attention, for following the school from start to the end. Congrats. I hope you learned some useful things and you'll be able to apply them in your own software. And I wish you a pleasant travel back home.
Thank you.
I'd like also to thank Asa, who had done a lot of work behind the scene that you don't see, but has been a great, great help. Thanks.